Decentralization Media.
Welcome back to our video series on Stellar, and today we'll be looking at how to create your own crypto tokens using the Stellar blockchain. And to begin this process, we'll need 3 separate accounts, and as you guys already know, we can use the laboratory and go to the account creator and generate 3 key pairs. Now the 3 accounts, let's say the first account, we'll name it as issuer. Now, an issuer is an account who's going to be issuing the token or the coins. And token or the coins. Then secondly, we'll need another account called distributor. It will be the account that receives the coins from the issuer and distributes it to the user in exchange for another type of currency, or it could be even XLMs. Now, as you can see, let's initially create our 3 accounts, and the third account being a user account for someone to use the exchange and get the money and get the coins. So as we generate key pairs, we have to fund them as well, and we'll be using the testnet for this. So I have an issuer key pair. And distributor one is funded as well. So finally, we have a user key pair as well. Let's see how we can start off the proceedings. So we have 4 different steps, not 4 exactly, 5 different steps that we have to follow. So that includes 5 different transactions. And to do this, initially the distributor will have to create a trust line towards the issuer account, saying that he's trusting the issuer for a particular type of asset. Let's see how we can do this. So we start off by getting the distributor public key and create a transaction from distributor, and the type of transaction is going to be change trust. And there are 2 types of custom assets available. It's alphanumeric 4 and alphanumeric 12. So we'll be choosing alphanumeric 4 today, because we have an asset name that's only 2 digits and 2 letters. And the issuer ID will be the public key of the issuer, and trust limit, let's say it's 1 million, and source accounts again public key of the distributor. So we go on to sign the transaction, and we submit it. Now that we're done with our first step, we may test it out by going to the endpoint explorer accounts, single accounts. Let's test it where it worked. So if we check the distributor's account, it will say he has another type of balance that is for this particular asset. So as you can see, in the balance section, we can see there's a limit of 1 million, and it's alphanumeric 4. Asset code is DM, and the issuer is the public key of our issuer account. Right. So now that is set up, let's go on to the second step. That is to that's to fund the distributor account with the actual tokens. Here the issuer is going to create a transaction. And it's a simple payment transaction. And the destination is going to be the distributor. Alphanumeric for code is DM. And the issuer code is issuer ID belongs to him. And he's going to pay $1 million. Then source accounts again, issuer. Sign using the issuer key and submit. So now that we have also funded the distributor with all the with 1 million tokens, let's have a look at it. Yeah, so the distributor is completely funded. Now, as you can see, the issuer is able to create these coins out of nowhere as long as someone is trusting him for a particular amount of money, amount of fund, and also for a particular type of asset. So once the issuer funds the distributor, we have to do something to lock the issuer account so that he cannot create any more of these coins. For us to do this, there is a way. It's called it's an option. So let's go and do this. We're gonna start off by using the issuer key pair. Right, the issuer is gonna do a transaction called an operation called set options. So it has some multiple options. However, we are going to choose master weight this time. Now this specifies the weight of the key pair that he is going to sign with. So if the master weight is 0, the account is basically blocked. The account loses its ability to sign or do any other transactions. Right. And let's sign it with the issuer secret key and submit. So this is a one-way street, guys. There's no way of going back from this. So we can see how this worked out. Now if we have a look at the issuer account, the signer's weight is 0. So when the signer's weight goes to 0, the account can't be used any longer. Too bad all these excellence going to waste here. No matter, it's a testnet. Now we've done 3 steps, and the 4th one being where the user comes into play. Now you notice that the distributor initially had to create a trust line in order to gain these assets. So the user is also going to have to create trust line. And for the same asset, same issuer, and the user can or cannot have limits, so we leave it empty. And the source account will be the user itself. On top of this, because we can have multiple operations and transactions, once we've done this operation, I'm thinking let's do step 5 here itself. No, it's alright. We'll just keep this separately so you guys have a better understanding. Now the user creates a trust line, So once the user has created his trust line, we can check the user account, similar to what the distributor had, should have an additional balance. Now here it's the maximum amount of limit, so because we didn't have a limit for him, so depends on how he earns. However, even the system doesn't have that many tokens for him. Alright, so let's head over to transaction builder once again and use the user key pair, and we're going to be doing a couple of payment transactions, and this is going to be a multi-signature transaction. Alright, so destination is going to be the distributor, because the distributor is going to act as an exchange here. And let's say we could have an exchange rate. Let's say we will give you 5 DM coins, I mean no, 1 DM coin for 5 XLMs. Okay. Now, and our second operation is going to basically be the distributor funding us with DMs. So this is a multi-signature transaction with 2 types of sources and destinations. Wait a minute, this source account is wrong. Maybe not. Okay, let's just have a look at it again. Payment, it goes from the user to the distributor, alright, and payment from the distributor comes to the user. This is wrong. No, this is wrong. Let's see how it works. Now we'll need to have 2 separate signatures here. One signature being the user. Sorry, that's the public. And the second signature being the distributor. Once the user sends this transaction, distributor has to return back with what it is. I mean, he'll have to check the transaction here, XDR, and sign it if it's correctly created. Okay, the transaction was a success. Finally, let's have a look at the user account, whether he received DM coins. Yes, he did receive 1 of the DM coins. So that's it, guys, for this video. We'll also have a look at this in the Stellar SDK using Golang. Thank you. Welcome back, guys. Let's have a look at how we can do this using the Go SDK. And so, as you guys remember, we created a crypto token using the Stellar Laboratory. Now, let's have a look at this, how we can do it using the Go SDK. Now, like said earlier, we need the issuer credentials, distributor credentials, as well as user credentials. Now I have a freshly created pair of accounts that I'm going to replace into the code. Hope you guys do it as well. That's when it actually works. because if you trust the same issuer multiple times and get funded, if you try to get funded again, if you try to fund your distributor once more, the transaction will reject. I mean, it will be unsuccessful because he already has the funds. So please do create new accounts and use them. However, the user account, you can use it as the same one, but he'll have multiple different types of assets. He could have DMs but with a different issuer key. Okay, so now that we have our 3 key pairs, we'll go into our step-by-step process. It's the 5-step process we have here, and we have 4 different types of functions that we're going to use here. Now, first being the change trust. This function will basically do what we did using change trust to do a trust line. So we're going to initially have the distributor key pair. He's going to trust the issuer for a particular type of asset, yes. And we have the testnet client here. I've used channels so that I get the asynchronous task done. Now you retrieve the distributor's account and build a transaction for that account, and we create the operation called change trust, and we have in the line section that will be your asset. It will have asset code and issuer public key. Then there's the limit for an asset and the source account being the distributor. Next we have the transaction builder itself. We add the operation, have the source account, have the testnet as the network, and time bounds to infinite. Then, like all the other transactions we did, we convert the transaction by signing and converting it to base 64, and finally submitting the base 64 to Horizon, and the response hash comes out as response. So that's the initial function that we have called, and we'll be console logging the response hash. Then the second step is issuer funds the distributor account with total coin allocation. Now, if you guys notice, all of these functions are in the main file itself, so you can easily navigate to them. Okay, sorry. So this again is a channel, is being the response that we send back, and so we retrieve the account details for the issuer, and he creates a transaction, an operation to fund the distributor with the same asset type, and creates a transaction, signs it, and submits. So now moving on to step 3, that's the lock issuer. Now this would be to do a set operation, set options. So he retrieves the issuer key pair, and issuer account is retrieved. Issuer account and set options. Now here we see that new threshold is there. So there's a master weight threshold and few other thresholds available. So we create a new threshold with the ID 0 and we assign it to master weight. But ID 0, I mean the weight as 0, and we assign it to master weight. Then finally, next up, we add it to the transaction builder and build the transaction with this operation. Then we sign it using issuer key pair. So remember, this is the step where we can't go back from. The issuer account will be locked. And finally, before we move on to the final function we'll have to repeat the first step once more. That is creating a trust line, but in this case it's for the user. Only if the user creates a trust line for that particular issuer will he be able to get the coins. And after he creates a trust line, we have offer coin exchange. Now this is the multi-signature transaction. Here we need both the user and the distributor key pair. You can have this in two separate functions depending on two separate endpoints. However, we are doing it in a single function here. So parallelly, both the user and the distributor retrieve the details, and we check for the user's balance, and the native asset being XLM, and the other balance being our DM. So first we check the wallet beforehand, then we create the transaction, and we have a native asset that the user is gonna fund the distributor with. Like we can see, we did 5 there, and we will receive 1 coin, 1 DM asset from the distributor. So 2 operations are set into the transaction. So the user signs it initially and converts it to base 64 and sends it over to the distributor. Distributor receives the base 64 and converts it to a transaction again, opens it, and he assigns the network and he signs this transaction. After he signs it, he converts it again into base 64 and submits to Stellar. So the multi-signature is done here. And finally, the user again retrieves his account details and checks for his balance. And this time he will notice there's a change. He would have received 1 DM and lost 5 XLMs. So shall we run this code and have it? Okay, go run main.go. So the initial step was successful, and the issuer has funded the distributor account, and now the issuer has locked himself. And finally, the user created a trust line now. Okay. And finally, we have the step where the user buys the coins. We see his wallet beforehand and his wallet after. He gains 1 DM asset and he has lost 5 XLMs. And finally, the transaction hash. So guys, that's it for the video. Hope you guys enjoyed it, and hope you guys also create your own crypto tokens. Please do leave a like, subscribe to our channel, and hit the bell icon for notifications. And put your comments down in the comment section below. Thank you.
Decentralization Media.